Hello everybody, this is Mrs. Snook with section 10.6, circles and arcs. Our objective today is we're going to name arcs, we're going to calculate the measures of central angles and arcs, and we're going to calculate circumference and arc length. First of all, let's name some arcs. So we have a circle over here, and the notation for this is that it is circle O. So I do a circle with a little dot in the middle and then O to name the circle. Minor arcs are the arcs on the circle that go less than halfway around. So I have a minor arc right here, AD, and I label that with an arc and then AD. We have another minor arc, DE, and so I label that with an arc and DE. Continue in the same manner. I have an arc from E to C, and I have an arc from C to A. It is acceptable to reverse the letters, so instead of saying arc AD, you could call it arc DA. That's fine. Semicircles. That means they go exactly halfway around the circle. So I have a couple semicircles here, starting at D, going all the way around to C. That's a semicircle. I passed through point A to get there, so I'm going to call this arc DAC. I have to have that letter A in there to indicate that it was the semicircle going through A, because between D and C there's another semicircle, but it goes the other way. Here's our other one. So to be clear as to which one I mean, I have to use my third point. So DEC is another semicircle. I have a semicircle starting at A and going to E. Passes through C, so A, C, E. And I have another semicircle that starts at A, goes to E, but it also passes through D. So this is A, D, E. Major arcs that contain point A. So a major arc means it goes more than halfway around. So for example, what if I start at C, go through A, and all the way around to E? That would be a major arc. I'm going to call that arc CAE. I don't have CAD as a major arc because that's a semicircle. Let's find another major arc that goes through A. How about arc DA around to E, or DAE. Let's find another major arc that passes through A. EAC, we have that one. I could do DAE, I did that one already. I think there's two more, but I think I'm going to leave that for you to do as an exercise. Next is the concept of the arc measure. So the arc measure is it's also a degree, and it's how far that arc is sweeping through the circle. So it's equal to the measure of the corresponding central angle. So I have an angle here, RST, that's 50 degrees. So then the arc RT would also be 50 degrees. The major arc, TQR, well, a circle all the way around is 360 degrees. So if I wanted the measure of the major arc, I would just do 360 minus the 50 and get 310. And the measure of a semicircle, because that's half a circle, is 180 degrees, because it's 1/2 of 360. Gives you 180 degrees. So now let's look at the measures of the arcs in circle C. measure of arc PR. So I'm going to go ahead and color in PR, this arc here. We're told the central angle is 77 degrees. So measure of arc PR equals 77 degrees. So I did A. B is measure of arc RS. So arc RS starts from here and goes to here. But check it out. Arc PS is a semicircle. So I'm going to do 180 minus the 77. And I get 103 degrees. Measure of arc PRQ. So let's color in PRQ. PRQ. Well, that one's our semicircle PS, plus we went another 28 degrees. So now I'm going to take my 180, that's my semicircle, and I'm going to add the 28 degrees. And I get 208 degrees.
So the fractions, the randomization is
last one, measure of arc PQR. So PQR, that's a major arc. So all I have to do is take the 360 for going all the way around a circle and subtract out the 77 from arc PR. So measure of arc PQR is going to be 360 minus 77.
There's a lot of aspects. How would someone be competent to review
360 minus 77? I get 283 degrees. All right, the next idea is the circumference of a circle. I think you've probably done this before. So the equation for circumference of a circle is 2 pi r. That's how we see it most of the time. R is radius, and the d is the diameter. Now diameter goes all the way across, radius goes halfway, so what that means is the radius is half of the diameter, or your diameter equals twice the radius. So when you look at this equation, C equals pi d, instead of a 2 and an r in there, we've substituted d for diameter. So essentially we're doing the exact same thing, just one's using the radius, the other is using the diameter. So let's find the circumference of a circle, given that the diameter is 24 inches. So my circumference would be pi d, which equals pi times 24 inches. I'm going to go ahead and multiply that on my calculator. So 24 times second pi. I get 75.39822 blah, blah, blah. I'm going to round to the nearest tenth, and the reason is the answer here is a whole number. So I'm going to go one more significant figure, and I get 75.4. Now what if, instead of doing the diameter, what if I did it with the radius? So now we'll do it with radius, the same circle. 2 pi r, which would be 2 times pi. The r here is only half the diameter, so it's 12. Punch that in your calculator, and you still get 75.4. Don't forget the units, inches. Our next idea is the length of an arc, which is just part of a circle. So what we're going to do is we're going to figure out how much of the circle we've got. So if I take the measure of the arc and I divide it by 360, that tells me the portion of the circle.
And you don't forget things like, oh, I didn't update the change logger.
And then the 2 pi r and the pi d, that's your circumference. So we're just going to figure out, which portion of the circle we've got and then multiply it by the circumference. On our examples, it says, what is the length of each arc shown in red? Leave your answer in terms of pi. So I'm not actually going to plug pi into my calculator and calculate it out. My answer is going to have pi written in it. So our first one, A, our arc that we're looking for is this minor arc between X and Y. Our diameter is 16 inches. So I have diameter equals 16 inches. And notice I have a right angle marked here. So that means the central angle is 90 degrees. So now to find the length, I'm going to do 90. I'm going to divide it by 360. That's our portion of the circle. And I'm going to multiply that by pi d, the 16. So 90 over 360, that reduces to 1 over 4 times 16, so that's a 4. Leave your answer in terms of pi, and our unit is inches. Now come over to B. This time I have don't have a diameter, I have a radius. So my radius equals 15 centimeters. And my arc, XY, goes through P. It's the major arc, so it's XPY. This is 240 degrees. So now my length is going to be 240 over 360. That's the portion of the circle, times 2 pi r, which is 15. So 240 over 360, that reduces to 2 over 3. And then I'm going to multiply it by 2 and multiply by 15. And I get 20. Leave the pi as it is. And this is centimeters. All right, so that's it for this video. I hope you all have a wonderful and fantastic day. Thanks a lot.